I want to first thank everyone for showing up to the talk and also wish you all best of health and hopefully everyone's being safe during COVID. So let's get started with this talk. I put this talk together because I am a developer advocate with Circle CI, and I'm constantly discussing Kubernetes and technology and containers and all these things with folks. And it clearly stood out to me that there's a lot of people or developers out there trying to get a hold of, understanding Kubernetes and trying to implement this technology, to better their software development processes or better their deployment mechanisms and management of application, just the overall management of applications. So I put this talk together to kind of give people a sense of what it takes to, get started with Kubernetes. So let's start with the agenda. I'm going to be discussing Kubernetes at a very, very, very high level, just to kind of introduce folks that are not aware of Kubernetes or what it does, right? Then I'm going to talk about some of the skill sets that I believe are really important for engineers or people, looking into working with Kubernetes, some of the skills that they should at least develop or have a fundamental understanding of. And then I'm going to dive into Docker and touch on the critical elements that, folks need to know about within the Docker runtime. And then we're going to just do a quick recap. So again, my name is Angel Rivera. I'm a developer advocate for Circle CI. And my primary job or function at Circle CI is to engage the developer community. And that could be, the public community, which is the conference type things that we do. It's also engaging with the internal Circle CI community, meaning my engineering team, my product teams, pretty much any unit within Circle CI. And the reason is I'm a liaison, right? So I'm I'm learning about how the community and the tech industry is using technologies, and then I'm bringing that back to our team so that we can build, more valuable features that will benefit our customers and developers. So again, I'm constantly engaging the community, and I'm learning a ton about how people are using software and technology. So again, I built this talk to kind of help the folks who are, investigating Kubernetes or researching Kubernetes, and then giving them some tips on how to, what things to kind of pick up on before you even get started. So before I get started, there's always this term or acronym K8s that's thrown around. And I just want to kind of start off by letting people know what that means. It's really simple, actually. Kubernetes, or K8s, basically stands for the word Kubernetes. The K is obviously the beginning of the word Kubernetes. And then the 8 is just basically the 8 characters in between the K and the S in Kubernetes. And the reason I brought this up is when I started learning about Kubernetes, I didn't know what that acronym stood for. And I still find people today, right? I could speak with folks that don't really understand what that is. And I'm going to be using it in my presentation throughout. So I just wanted to kind of set the stage and level set everyone with that. So the first thing you should ask yourself before even, going in and working with a thing like Kubernetes is why? Why would I start using Kubernetes, right? And I want to give you a few common reasons, to again, level set people's expectations about Kubernetes. So if you're interested in implementing, faster development cycles, building applications in a consistent and rapid pace, then Kubernetes is a tool and a platform to enable you to do that. It's also a tool that will help you enable any kind of DevOps or CI/CD practices that you're implementing within your teams and your software development cycles. So if you want to, again, increase the velocity of your software development life cycles, definitely look into Kubernetes as a tool to facilitate that. Kubernetes is also helpful in cutting infrastructure costs, right? So with the ability to run multiple workloads or services, in a a one-stop shop kind of cluster, it definitely helps with managing costs, because if you're running things in, like, let's say a cloud provider like AWS or Google Cloud or Azure, your architecture of your infrastructure could be really inefficient and expensive, right? So if you're looking to kind of optimize how your architecture is comprised, and also the efficiency of how your applications are being and your workloads are being deployed and operated, definitely look into Kubernetes to help cut some of that cost. And finally, one of the biggest advantages of Kubernetes is definitely where you can help with the performance of your applications and the operation of your applications and services. So Kubernetes is definitely a great platform if you need things like high availability, if you need your application and your resources to scale, right, with elasticity. So, it's dynamic scaling, and it will basically enable you to consume resources as you need them, right, and then release them when you don't. So if you're looking again for some availability options or high availability performance features, definitely look at Kubernetes, and it's also great for scalability requirements. So that was, again, a couple of reasons why you would look at Kubernetes. Now let's get into a little bit of the brief intro to Kubernetes. So Kubernetes, again, is a platform for orchestrating containers. And the main thing I want you to take away from this slide is, remember that Kubernetes is an open source container orchestration system. And without containers, pretty much Kubernetes is just a bunch of services that know about Kubernetes, right, in the cluster. So again, the thing I want to stress here is the main takeaway from this slide is Kubernetes is an open source container orchestration system. So let's go a little bit back in time. When I started developing software and deploying software a few decades ago, the traditional deployment mechanism was, you had an application, you would deploy it within an operating system that sat on top of a hardware, right? It would be a physical server somewhere in a data center, and occasionally in some companies, like broom closets, right? So when the internet was starting out, I can tell you, I ran servers out of a broom closet for my company in some cases, right? The problem with that was, as our applications, right, gained steam and people were using the application, and our workloads kind of scaled up, right? We had more demand on an application. It was really hard to provide more resources to basically, have adequate resources for the service to fundamentally, provide the information that was being requested. So we needed to scale. And the way we scaled those systems where we had to add more hardware, right? Literally a new server, right? That required more electricity, that required more networking bandwidth, right? So there's a lot of other dependencies with scaling in that old traditional deployment model. And as you could imagine, it would get really, really, really expensive. So let's fast forward a few decades. And the advent of the hypervisor added a layer, right? So we're looking at virtualized deployments, added a layer of efficiency. So what that hypervisor did was it enabled us developers and sysadmins and SRE people to leverage the existing hardware at a much more efficient manner, right? So the hypervisor is basically software that sits on top, in between the virtual machine, your application that's isolated right in a virtual machine, and it communicates with the underlying hardware and operating system. So with having that hypervisor there, you're able to kind of squeeze out a lot more juice from the server. And get, maximize the optimization of the resources that you're consuming. And that was a game changer, right? So we were like super happy. I remember developing against, virtual machines, or at least developing applications and then package them into virtual machines, which would then run on this hardware. So you could get a lot more out of your existing hardware, again, using, virtualization and the hypervisor. Now, fast forward to today, we actually, if you look at the container deployment, we've actually gotten a lot smarter, right? So no longer is the hypervisor kind of sitting in between your application and the operating system and hardware. We're now running what we call container runtimes. These container runtimes are similar to the hypervisor, but they're a lot more efficient at running these workloads, right, on the same hardware. So, and then that also gives us the ability to create these lightweight containers, right, that don't have all that dependencies and all that fluff and overage in dependencies that the virtual machine has, right? So that's the evolution of kind of software deployments and running applications. So let's talk about Kubernetes. This is where I'm going to get a little bit, decomposing it, meaning talk about the critical elements of Kubernetes and concepts. So the first thing you want to learn about in Kubernetes is about clusters. If you're already familiar with like how server clusters work, then you're a leg up, right? And it's very similar to that concept, right? So the way it works is a cluster is composed of basically two different types of machinery. So let's talk about the control plane first. So in this diagram here, we have, if you kind of broke it apart and devolved it, the control plane is basically like, let's call it a server. And that server the control plane houses all of the critical Kubernetes services. So the cluster itself is in a control plane, right? All the functionality for the cluster, and it's the brains of Kubernetes for the most part. It contains all the critical services that then control the other nodes inside of your cluster. So if you take the control plane as like kind of the brains, right, of Kubernetes, the worker nodes or the other nodes in Kubernetes are just that. They're worker nodes. They're basically the horsepower behind Kubernetes. So most of the work is done on these what we call worker nodes in Kubernetes. I just wanted to kind of break the cluster apart and describe have you have a good understanding of what they are. So this slide I will change with all the things going on. But basically, I'm going to call, instead of it masters, we're going to start calling these primary nodes. So again, the Kubernetes primary nodes are where the control plane services run. And again, it's the brains of Kubernetes. So the primary node is the node that, again, controls the worker nodes, understands what's happening on all of those worker nodes, and then it can orchestrate, like, deploy X amount of instances of an application to worker node 1, right? And then it can also deploy another set of instances of that same application, right, to kind of balance that load to, let's say, worker node 2. Again, keep in mind that the control plane is the brains of the Kubernetes cluster. Here's another example, right, diagram of that whole situation. And the one thing I want you to take away from this slide is notice that in the worker nodes, we have a bunch of common services running, right, that are Kubernetes related. And the other key thing you want to look at here is all of the worker nodes pretty much have a container runtime running. And that container runtime is defaulting to Docker. So let's talk about those worker nodes. I already mentioned that, they are like kind of the muscle behind your Kubernetes cluster. This is where all of the work happens, right? So your applications are deployed, all the processing happens on worker nodes, right, within containers. And containers, within Kubernetes, you have this concept of pods. And all pods are really a grouping of containers. So if I have a web app that I'm deploying, and I want to run, let's say I have a 4-node Kubernetes cluster, right? Or a 5-node, and one is the control plane. Then that cluster with the 4 worker nodes, right? I could spread my workload for that web app into 4 different pods, right? That live on those 4 different worker nodes. And then within that pod, I can run like maybe 10 instances of my web app, right, inside of a container. So again, pods are like the most critical component within Kubernetes, because again, Kubernetes is a container orchestration system. And then, the final thing I wanted to talk about was the container runtime. Again, I want to stress that Kubernetes is a container orchestration system, and this container runtime is critical, right, inside of the Kubernetes cluster, and that's what we're going to focus on today. So before we get into Docker and the container runtime, I do want to talk about some of the skill sets that I would suggest folks who are dipping their toe into the Kubernetes sphere learn. I speak to a lot of people, right, and we're all humans, and we can't know everything. And Kubernetes, on the onset, can be very intimidating because it is a robust and can be at times complex system. But if you have, certain skill sets that I'm going to talk about, it should make your learnings of Kubernetes and experience with Kubernetes a lot easier to digest and understand. So the first thing I would suggest is if you're not already involved or implementing or knowledgeable in CI/CD and DevOps practices, I would highly recommend that you start looking into them because again, Kubernetes is a great platform for facilitating these CI/CD and DevOps principles. I speak to a lot of folks who, they use CI/CD in a sense, right? They're developers and they push their builds to a CI/CD platform, but they don't really understand what's happening and why they're doing that. It's just something that they were told to do, and it's like kind of a segment in their process that needs to be done. But if you really want to understand, CI/CD and DevOps principles and the benefits of that, basically it enables you to securely test, build, and deploy your applications. It also enables you to monitor, right, these applications and these processes using automation. And of course, right, it's continuous, right? So when you're talking about continuous integration, it's continuous. So things happen in a cycle, a repetitive cycle, right? And it iterates over and over. The other skill that I would recommend folks look at is security, right? And getting knowledgeable on role-based access controls, which is that RBAC there. And basically, Kubernetes as a platform operates in this manner. And quite frankly, most modern day platforms run in this manner when it comes to security, right? So role-based access controls, I would definitely recommend getting a little bit smarter on that, right? And having, a fundamental understanding of this. So networking is big, right? So in today's world, everything's connected, right? You're dealing with the cloud. Without a connection and without networks, you pretty much have nothing, right? You have a standalone machine. So definitely look into the fundamentals of networking, understand, how things communicate, things like DNS, IP addresses, right? Those are the things I'm talking about. I don't want everybody to come out and try to figure that they need to be a network engineer to get Kubernetes up and running, but you do need a fundamental understanding of how things are interconnected, and it shouldn't take you long to ramp up. This is really important as well, monitoring logging. So again, right, you're deploying multiple workloads to a platform. That could mean you're deploying like 10 different applications within a cluster, right? And how do you ensure that your applications are operating the way you want them to, right? Or figuring out, when you have issues, how do you figure out and debug? Obviously, right, if you're a developer, you're doing this already, but it's usually locally on your machine. Whereas if you're deploying things to like a platform like Kubernetes, you definitely need to understand where your logs live, right, where your applications logs are located, and how you can quickly, determine, find them and determine what the problems are, and then have solutions to those problems. The other thing I would mention here is get familiar with maybe some monitoring tools as well. So like right now there's, if you're working in DevOps, you're usually probably on the SRE side, understanding, tools that give you that telemetry, that information from your application from within this Kubernetes platform. And there's tons of them out there, right? I'm not going to name any vendors right now, but you can definitely look up a few and, pick one that is suitable for what your needs are, but definitely have an understanding of automated monitoring and logging, also understand where log files live, and have a fundamental understanding of how to read them as well. So if you're trying to, so the way Kubernetes kind of is deployed, it's I don't want to say it's designed as a stateless kind of platform, but it is a platform where folks are using it to really try not to save data in a sense, right? So like if you're trying to run a database on Kubernetes, you can do it technically, but you will need to persist that information. And if you're going to do something like that, right, or if you're going to save data within that cluster, you're going to need to understand storage or block storage, right? So, just have an understanding of what block storage is and the types of storage that the platform Kubernetes supports. And, just be able to, when you have the need to store data, you'll have an understanding of that. APIs, application programming interfaces. We're developers, right? Or most of us are developers. We definitely understand what APIs are, but there's different types of APIs, right? You have RESTful APIs, you have socket type APIs. There are all kinds of protocols for different types of APIs. I would definitely recommend, you understand the Kubernetes level APIs. Just so you know, Kubernetes is kind of built with APIs as first-class citizens, meaning, you can do pretty much anything in the platform using an API. So again, right, have a basic fundamental understanding of the APIs within the Kubernetes space. YAML. YAML is really important. If you're not familiar with YAML, I know when I speak to developers off the top, they are not familiar with YAML for the most part, right? Like most developers, especially like in the front end space. So YAML is basically kind of the de facto data structure used in the cloud native projects and products these days. So the reason why YAML's kind of popular in a sense in that space is because, again, it's a data structure, but it's unlike JSON, it's a declarative data structure. So it's a lot easier to read on the eyes, like human readable. And again, it's one of those de facto kind of default data structures that is leveraged throughout the cloud native ecosystem. We use it at Circle CI to configure what we call pipelines and in our product, and our developers use it as well. So yeah, definitely have an understanding of YAML so that you can kind of grow and operate nominally in this infrastructure. Infrastructure as code, really important as well. This is a skill that I would recommend every developer to kind of develop over time. And what it is basically the idea is you can codify your cloud resources or your server resources, right? It's no longer like I would say like public cloud thing anymore. This applies to a private cloud. So if you have like VMware, ESX, or Citrix, type Zen type platforms running in a private data center, you can now leverage products out there that are infrastructure as code type products. HashiCorp Terraform is one, and Pulumi is another one, a new kid on the block. But they're both again, infrastructure as code type tooling that I would highly suggest you as a developer, regardless if you're using Kubernetes or Docker or any kind of, what I'm talking about today, definitely invest some time in learning what infrastructure as code is and develop some skills in using some of those tools. By the way, the vendors that I mentioned or the projects I mentioned, they're open source as well. So you can actually contribute to those projects, but definitely understand infrastructure as code. Yeah, and finally, the skill set that you need the most when you're endeavoring to jump into Kubernetes or use Kubernetes is have a deep understanding of containers, right? Because again, Kubernetes is a container orchestration system, right? And at the heart of it, without containers, Kubernetes again is just a pile of its own services running on machines. So having said that, let's talk about Docker real quick and container runtimes in general. The reason why I'm picking Docker for this is it is the kind of de facto Kubernetes container runtime. There is another one called Containerd, and Containerd is an open source platform or project, and it's definitely a principle in underlying Docker runtime. So again, Docker is basically a platform for you to package up your applications into a container runtime. So and that's cross-platform, right? So anytime you can run a Docker client or a container runtime, you should be able to run your application within those containers, right? So it's a nice level playing field that you can run your application across multiple operating systems, as long as it supports running a Docker runtime or a container runtime.
Hey, Angel, real quick.
Yes.
Just before we get too far ahead, I put a question for you right there in the chat.
Yeah. All right. Sorry about that.
You fine?
Can you read it to me?
Yeah.
I'm having a time.
So about stateful data in Kubernetes, is there a
Sure.
certain level of complexity below which you do not want to use storage classes? I've heard that storage classes are too complex for smaller workloads, but I don't know what the threshold would potentially be.
Yeah, I see. Yeah, so every case is different, right? So I would recommend you do some analysis on the workloads that you're trying, the reasons why you're trying to persist that data, and then the biggest pain point with storage within like Kubernetes is there's two things. One is performance, right? And the other one is being able to reestablish the storage. So the way containers works are, like I said, they're designed to be stateless. So Kubernetes doesn't care about like a specific container. So it's designed to kind of scale up and down and not care about like if someone's connected, right? You can set parameters to drain a container before you start basically destroying them or killing them. And the problem is, let's say you have a container that has this attached storage. How does Kubernetes, if it destroys that container, how does Kubernetes know that this new container that's coming up needs to be attached, right? So it's like a mapping problem. I think they're getting they're progressing in that in resolving that, but that's one of the main problems. And the other again is performance, right? So if you need high throughput I/O from your application to that storage mechanism, then you need to really have that optimally designed and then and tested, right? And then you also have to monitor and make sure that your performance is up to snuff, which comes back to that monitoring logging. So I would suggest that you kind of architect your deployment of your application within Kubernetes and look at the requirements that you need. I hope that answers your question. But as far as like the individual use case that you mentioned, I'm not sure. I would need a little bit more data and information to try to help you with that.
This sounds like a perfect breakout room conversation.
Yeah. So is there any other questions or?
Let me take a look real quick. Yeah, this is a good break for sure. I'm not seeing any.
All right, cool. All right, this is a great point to let's take a look at Docker, right? And start decomposing the key elements that I believe folks should know about Docker. If I can get my slide going here. All right, cool. So again, the main component to Docker is the Docker engine. So the Docker engine is also, it's another name for the Docker runtime. So if you hear me jumping in between these two terms, they mean the same thing in my mind. And I believe in Docker's mind as well. So yeah, the Docker engine is, again, the runtime. And that runtime is the software that helps, software and services that helps Kubernetes run your application or manage and run your application. So is that right? Okay. Yeah. So this is kind of a nice diagram of, decomposing some of the key elements within the Docker runtime. If you look at on the borders, you have those blue blocks, right? The Docker API and Docker CLI and plugins. Obviously, the Docker API is a way for you to programmatically, connect and control the Docker runtime. The Docker CLI is more of a manual human interactive type interface, right? So obviously, you can use the terminal, right, and then type some commands and use that Docker CLI to control the other components within the runtime. The things I'm going to cover today is the Docker build environments, and then I'm going to talk about probably the distribution pieces, and and I guess some of the networking with the examples I'm going to show. And with the other blue block there with the plugins, you're able to create these extensibility type software, right? So if there's some capabilities that are not default included in the Docker runtime, you could actually go ahead, since it's open source, I believe there's a community edition, you can go ahead and open up some software, start writing some code, and create a plugin that will add the capabilities you need. So maybe you want to enhance your volumes capabilities within the runtime. You can write plugins to do that, right? So just some food for thought there. So Docker has basically two main components that we as developers are going to interface with. Docker is composed of images and containers, right? So we always talk about containers, right? Running containers and making sure they're active. An image is a template for those containers. So I always like to use the example of let's use the example of a cookie cutter, right? So let's say I've rolled out some dough and I want to make 10 cookies. The Docker image is basically the form and shape of your Docker container. So if you look at the analogy of the image being equivalent to a cookie cutter, Docker image, right, is again equivalent to your cookie cutter. So that's the form and shape of your container. So if you have an image, you can then cut out, right, or build containers using this Docker image. And basically, when you're smashing down that cookie cutter into your dough, right, you're cutting, a cookie, and that is equivalent to creating a container, right? So again, think of your Docker image as your cookie cutter, and then you're just as you create, use that template or that cookie cutter on your dough, you're creating containers. So if you do that 10 times, right, you smash it down 10 times into your dough, you should have 10 cookies, which should be equivalent to 10 containers. Again, I know it's a little food and technology, right, related, unrelated maybe, but I like to use that analogy, and it comes across pretty clear to folks that don't understand. In order to create those images, though, right, you have to build them. And obviously a cookie cutter is created probably in a factory or on a 3D printer these days, right? But at the end of the day, you have to build that. So the way you build that Docker image is by using a Docker file. And I have an example of that here, right? This is an actual Docker file of the demo I'm going to show you in a few. But basically, it's a similar YAML-esque, I would say, kind of look and feel to this Docker file. But we'll go quickly through this. The Docker file, again, is the instruction, right, to build your image. And once you have that image built, you can then reuse that, right? You can spawn Docker containers from that image. So let's start with the first line. First thing I'm doing is I'm inheriting. So every Docker container inherits from some other Docker container. Docker has basically like a website, or we call it a repository registry online. It's publicly available, and it hosts thousands and thousands of Docker containers. It's called hub.docker.com, and that's where kind of like everything comes from, right? As far as like the inheritance. So what we're doing is saying, all right, node from the node 12 version 12 container or image, I want to basically inherit everything from there. And then you start working. So the node team publishes an official node Docker image up to the Docker Hub, and it's publicly available, right? So by default, the Docker runtime goes to that Docker Hub site and pulls down your images. Now you can change that behavior. We're not going to talk about that now. It's a little bit more advanced, but you can change that behavior to point to like a private registry, and that's okay too. But we're using the public one. So the next line is the working directory. So within, like, once I pull that image in, I'm going to say, all right, I want to basically put my application or work in this directory, which is user source app. And then from there, I'm going to copy in the package JSON file, which has basically all of my dependencies that I'm going to use in my application, right? And then do you see that run command? It's just going to run an npm install, right? And then what's happening is going to install my dependencies. Once I'm done with that, I'm just going to copy all of my application source code over into that new image. And once you have that, you expose port 5000, which is the default, right? It's a web app for that. And then the last bit in my Docker file is basically telling the container, or setting the parameters for the container when it spawns a new, right? When Docker spawns a new container based off of this image, it's going to start my application using npm start. Real simple, right? It's actually really simple to understand and digest, hopefully, and that's the Docker file. So let's jump into a demo and build some Docker. Yeah. Let me see if I can jump over to. Nope. Let's go back one. All right, cool. So here I have a terminal, and as you can see, I did an ls, and I'm showing you a project, right, sitting on a server somewhere. And basically, what's happening here is, I have a project that's sitting on GitHub, and I can share this with all of you after. But basically, it's a Node.js application, simple Node.js that I use for demos. But the key thing here is the Docker file, right? So you saw the Docker file in the previous slide. So what I'm going to skip over showing you that. But what I'm going to show you is how to build this image. So you have to install the Docker runtime, right, on your laptop or server or whatever. And what I want to do is say, all right, what I want to do is say Docker, right? That's the client. And then we're going to use the build command. And then we're going to use a -t flag, which is a flag for, or a tag for your image. So this is how you would name your image and label it. You can use multiple tag flags if you have like, the basic is like just the name. And then you can also put like when we saw the version 12 of Node.js on the back end, that was another tag, right? So, but we're just going to call this a Rivera, which is on hub.docker.io or .com. This is my username, right? And if you go to my username, my profile on that page, you'll see this image or these images up there as well, if I push them up. And then we're going to just say node, I think I call this project, Node.js -circle CI. And then we'll just say latest, even though you don't have to, by default, it'll do it. And because I'm in the root of the folder, my Docker file is there. I just do a absolute dot there so that, by default, the Docker build command will search for that Docker file that's sitting in my repository. So we hit enter, and what it's doing here, as you can see, right, it's pulling down from the Docker Hub website or registry. It's pulling down all the layers, which are bits of cached kind of commands from that image, right? And it's pulling it down into my local machine here, and then it's also going to then extract those bits, those layers, and completely form a new image on my machine. So then the Docker file, remember I had the next step is to set the work directory. It's doing that for me now. So once that's all done, right, my application's packaged up, and this should take, a few minutes. By the way, you only need to build this once, right? So when you change your application, you'll probably have an automation to do this multiple times for you, which is where Circle CI comes in, right? And gives you that automated, every time you do a git push upstream, we could run this for you and build these containers and push them out. So now I'm done, right? So let's clear that out a little bit, give us some room to look. And if you ever want to see how many images, or just list your images within the Docker runtime, you just say Docker images, and now we have that image, right? And because I inherited from the Node image from Docker Hub, you always have to, get the original one you inherited from, and then here's my new image, right, that I just built. So that's pretty much how easy it is to, define in a Docker file your image, and then build a local image, right, that is extended upon from, which inherits the original node. So let's jump back to the slide deck. So that's the Docker build, situation or functionality. So now that we created our cookie cutter, let's create some cookies, which are the containers, right? So again, the containers are the actual instances that are deployed, right? So we have our image. Now we can run our application within the Docker container, right? And that's, again, where you spawn runtimes of your runtimes of your application within containers. So the way you would do that is the command is like we did with Docker build. The command to spawn a new container is Docker run. So let's go ahead and do a quick demo of that, and then answer some questions, I guess. So let's see. All right, Docker. So in order to spawn a new one, right, we're going to do Docker run, and we're going to make it a daemon. And then we're going to also add this RM flag, which basically creates a temporary container. If I don't do this, then I will have, actually, you know what, let's take that out and disregard what I'm talking about, because I'll show you some other things later. But basically, we're going to do a Docker run. And then since it's a web app, we're going to do a port. And then we're going to say, let's just open up the port, right? So we want the egress to be 5,000, and then we'll just do a direct 5,000 evenly to that. So basically what you're saying here is I need this container to have an accessible port on 5,000, and then translates over to 5,000 to the application. You could do something like 80 or, on the front end there, and then it'll translate to 5,000, which is very common. But right now, since it's local, we'll do it this way. And then the next thing is, let's just name this thing, right? So we're going to call it a name, and then we're going to say test 01. That's our container instance, right? We're just naming it. And then finally, we need to give it the image that we want it to use, which is Rivera Node.js Circle CI, right? And that's going to be it. It's going to pull this, since it's locally, it's going to be really quick because it's on my machine. But if it doesn't exist, right, it will download it like it did earlier from Docker Hub, if it exists there. So now that basically it's that simple, I created and started a new container. So let's just see what's happening with this container, which is, if you want to look at running container, just type Docker PS. And as you can see, right, I have a container that was created 15 seconds ago. It's been up for 12 seconds. So the next thing I would like to show you is the application running real quick. I know I might be running out of time, but we'll do this real quick. UB Docker is my server, and there it is, 5,000. Hopefully, yay. So we have the container running, right, in my UB Docker server on port 5,000. So let's jump back over to this, right? So now that I have that running, let's go ahead and do, let's say I want to stop that container from running, right? So we could do a Docker stop is the command, and then you give it the name of test 01, right? That's the name of our container instance, right? And test 01 should be stopped. So if we do a Docker PS, we should see nothing. But if you want to see inactive containers, right, or all containers, there it is. PS-A is the flag for all, and then it has exited. So the application is no longer running, right? If I do a refresh here, no more, right? And let's say, all right, I want to start that container up. We can just do a quick, probably just type that, but, and we can do that, right? It's back up and running. And if you do a PSA, up, right? And then jump over here, refresh, applications back up and running. So there you go, right? We have pretty much created a container, and we built a container, we created a container, we ran a container, we stopped a container. And then the next step would be, right, once you have all that stuff packaged up and ready to go, you would deploy this container to Kubernetes. I'm not going to get into that because that's going to be another talk that I'm developing. It's kind of to segue from this one into another transition into another Kubernetes talk. But basically, container deployments within Kubernetes are, again, creating a pod and then layering in there or spawning new containers like we did, right? So imagine Kubernetes, if you had 10 of them running, Kubernetes is monitoring them for health. If the application maybe is a memory overflow or something, or something happens where the application is just not functioning and is unhealthy, Kubernetes will basically kill it, right? Kill that instance and then spawn a new one to replace it. So real quick, let's recap. Docker images, right, again, are the template, right, for your Docker containers. Here are some of the critical commands that you definitely will be using as you develop containers and package your applications in containers. There's tons of other useful commands, right, for building images, but these are just the main ones that you're going to be using. Then we're going to talk about or recap on Docker containers. These again are some commands that are really critical for when you're playing with Docker and building applications and also running these applications. And finally, again, here are the skill sets. I got to stress this as well. These are really important. I think, it's definitely worth your time and investing to understand all of these elements within technology, just for your professional progression and also, to be knowledgeable when you're dealing with other tools as well, not just Kubernetes, right? These things will apply in other platforms as well. So here's some resources for folks who are interested in learning more about Docker and Kubernetes. This Micro K8, the second in the list there, is a really cool project by Ubuntu, Canonical, and definitely check them out. You could, create. So if you're a developer and you don't want to stand up clusters and all that, there's tools out there like this, like Micro K8s and Minikube that you can, stand up clusters and write applications against Kubernetes and see how your apps perform in a Kubernetes style environment. And also the community sites, right? Like there's tons of information there as well. So I want to thank everybody, and hopefully there's some questions. I'm here to answer questions and engage with everyone. And you can reach me at Punk Data on Twitter, GitHub, pretty much that handle. If you look it up, I think on social, that's me. So thank you everyone again for having me, and I want everyone to also stay safe, and look forward to hopefully meeting some people or everyone in the future.